The objective of this lesson is to generalize a formula for the surface area of several three-dimensional shapes and calculate the surface area using substitution. In previous lessons, students created nets in order to calculate the surface area of three-dimensional figures. Students are not required to memorize formulas for surface area. This lesson is about reasoning that may be used to make calculating surface area more efficient. Jason is making a plexiglass display case for a baseball signed by his favorite baseball team. If the edge length of the cube is 3 1/10 inches, how much plexiglass does he need to create the display case? Start by drawing a cube with the edge equal to 3 1/10 inches long. Every edge on a cube is equivalent. One way to calculate the surface area is to use a net. Because this is a cube, each face of the net will have the same dimensions of 3 1/10 inches by 3 1/10 inches. One way to find the surface area would be to find the product of 3 1/10 times 3 1/10 and do this 6 times for a total surface area of 57 6600 square inches. Another way to find the surface area would be to take 3 1/10 squared and then times the product by 6 for a total surface area of 57 6600 square inches. Jason will need 57 6600 square inches of plexiglass. Both methods resulted in the same answer. The second method was much more efficient. What if the side length was unknown? Let's use the variable x to represent the side length. The same expression would have an x in place of the 3 1/10. The formula for the surface area of a cube is x squared times 6. Let's create an expression to represent the surface area for any rectangular prism with the L as the length, W as the width, and H as the height. Let's begin by drawing a net. Then label the net with back, bottom, front, top, left, and right. Then label each face with the appropriate dimensions using variables L, W, and H to represent the length, width, and height. One way to calculate the surface area would be to add the surface area of each face, starting with the back, length times height, plus the bottom, length times width, plus the front, length times height, plus the top, length times width, plus the left side, width times height, plus the right side, width times height. Notice that the front and back have the same dimensions. The bottom and top have the same dimensions, and the two sides have the same dimensions. Another way to solve for the surface area would be to take the dimensions for the front, top, and one side and multiply each by 2. The expression would be length and height times 2, plus length and width times 2, plus width and height times 2. Can this expression be simplified? Yes, each dimension was multiplied by 2. So the expression can be written as the sum of each dimension times 2. The objective for this lesson was to generalize a formula for the surface area of several three-dimensional shapes and calculate the surface area using substitution. We met this objective by generating formulas to calculate the surface area of three-dimensional shapes for any size side of cubes and rectangular prisms.